Our previous video was dedicated to exploring this formula, and so let's go ahead and apply this formula. So the first problem we'll look at, find the arc length of y is equal to 1/12 x cubed plus 1 over x over the interval where x is ranging from 1 to 3. So if you were to graph this function, you would find that it looks something like this, where like here's 1, here's 3, and so we are looking to see how far is this from here to here. That's the calculation we're going to do. So we're thinking of this as f of x. F prime of x is going to be, let's see, that's going to be 1/4 x squared plus, minus 1 over x to the minus 2. I'm taking the derivative of this right here. And so the thing that we are integrating is this quantity right here, the square root of the derivative, square root of 1 plus the square of the derivative, and we'll be integrating that between 1 and 3. So S is the integral from 1 to 3 of square root of 1 plus f prime of x is 1/4 x squared minus 1 over x squared dx. And so in a certain sense, we are done. That we have this formula and we use it. Here is the integral. And so we can go ahead and integrate this, then we are done. However, let me go ahead and evaluate this integral, because as we'll see, there are some common tricks to look out for when you're doing these kinds of problems, these kinds of arc length problems. There are some kind of standard algebraic manipulation tricks. And so this one is going to illustrate a common algebraic manipulation trick that will actually allow us to evaluate it. And if you don't know these tricks, it can be very difficult to evaluate this integral. And I just realized, what am I missing here? I made a bad mistake. I forgot to square that. So once again, what is going on here? The square root of 1 plus f prime of x, the square of that. And so when I first wrote that down, I forgot to square that. So you want to change that in your notes. Okay, so let's talk about how we can simplify what's under the square root. So I'm just going to pop out this is what's under the square root. And I'll include that square there. When we expand everything out, we get 1 plus 1 over 16th x to the 4th. And there's going to be minus 2 copies of 1 over 4 times x squared times x to the minus 2, and then plus 1 over x to the 4th. Okay, just a little bit of simplification here. Let's do this. So 1/16 x to the 4th, and then we're going to have plus 1, and this is going to be x squared times x to the minus 2 is just 1, x to the 0. So minus 1/2 times 1 plus 1 over x to the 4th. And so we can combine those as plus 1/2 plus 1 over x to the 4th. And so what we are integrating is the square root of this. And so the big question is, so let me just introduce in that square root from before. The big question is what's under the square root a perfect square? Because if it's not, if I just give this to you and say integrate this, that's a difficult integral that, without simplifying it. It would be very, very tricky to integrate square roots without doing some kind of substitution, and we don't really have things outside the integral to take care of our du when we replace dx with du. That just doesn't really seem possible here. So our goal is what's under the square root a perfect square? And the answer turns out it is. So something that we can realize here is that this quantity, again going back to the thing that's under the square root, this is equal to 1/4 times x squared plus 1 over x squared squared. Because if you expand this, let's check that by expanding this, we end up with 1 over, let me get rid of that parentheses, 1 over 16th x to the 4th plus 2 times the product of that plus that squared. And it's easily seen that those two are the same thing. And so the thing that we realize here is that the square root of 1 over 16 x to the 4th plus 1/2 plus 1 over x to the 4th is equal to the square root of 1/4 x squared plus 1 over x squared squared is so the square and the square root cancel out, and so 1/4 x squared plus 1 over x squared. And so now what do we have to do? We are integrating from 1 to 3 1/4 x squared plus 1 over x squared dx, and that is a very easy integral for us to do. 1/12 x cubed minus 1 over x, plug in 1 to 3, 17 over 6. So this is a very, very common trick. This is why I wanted to use this problem. You know, our arc length formula. Our arc length formula is integrating the square root of 1 plus something squared. And so quite often that's a difficult calculation to do. Here this is, so, you know, without simplifying this, you know, integrating this would be very difficult. So we should be looking to see if what's under the square root is a perfect square, and if so, use the perfect square to simplify things. Okay, so what's going on here? One question you might be wondering about is how to spot this. How to spot that this is this squared. So let's go to some scrap paper here. So 1 over 16th x to the 4th plus 1/2 plus 1 over x to the 4th. So how to spot that this is a perfect square? Well, first thing is you should really, really, really be thinking and hoping and praying that this is a perfect square. You know, otherwise the integral will be very, very difficult to do. And so you should be thinking about it. Let's try to pull things out here. So let's factor out a 1 over 16 from everything. And now let's also pull out a 1 over x to the 4th. So that's going to make this x to the 8th plus 8x to the 4th plus 16. And so now you might be able to spot here that what's going on here, this is x to the 4th plus 4 squared. Because, you know, the powers go x to the 0, x to the 4th, x to the 8th, and 8 is twice the square root of 16. So all of those are kind of things you should be thinking about when you're trying to factor this. If you're uncomfortable factoring stuff with x to the 8th and x to the 4th and stuff like that, we could just replace temporarily z is equal to x to the 4th, and now this is z squared plus 8z plus 16, and that's something that maybe now you can see that z plus 4 quantity squared. Okay, so this is our first example of crunching out things. First example of applying our arc length formula. So let's end this video with our first pre-class problem. So find the length of a curve, y is equal to natural log of cosine x. And x is running between 0 and pi over 3.